Hi everyone, this is your math guru. In this video, I'm going to solve the following number sequence questions with sigma notation. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. The first question reads, if the summation of 3 times 2 to the power of 1 minus k is equal to p, write down the summation of 24 times 2 to the power of minus k from k equals to 1 to the maximum 20 in terms of p. To start with, we need to know what the expansion of summation of 3 times 2 to the power of 1 minus k from k equals to 1 to 20 will give us, or what it will be that will be equal to p. So therefore, we start from the lower limit, which is k equals to 1. And if k equals to 1, putting k equals to 1 in the summation or sigma notation, we have for our first term, that will be 3 times 2 to the power of 1 minus k. And remember, k equals to 1, so we have 1 minus 1. That will be 3 times 2 to the power of 1 minus 1, that's 0. And any number of variable to the power of 0 is 1, so that's 3 times 1, which is 3. That will be our first term, T1. If k is equal to 2, we're going to substitute k equals to 2. We have 3 times 2 to the power of 1 minus 2. That will be 3 times 2 to the power of 1 minus 2, that's minus 1. And that will give us 3 over 2. Making our exponent positive, that's a second term, T2. For our third term, k equals to 3, we have 3 times 2 to the power of 1 minus k, that's 1 minus 3, and that will give us 3 times 2 to the power of minus 2, that's 1 minus 3 will give us minus 2. That will be 3 over 2 to the power of 2, that's 3 over 4. And that will be our third term. That means our sequence would be our first term, that's 3, plus our second term, 3 over 2, plus our third term, 3 over 4, and so on, till we get to our 20th term. And that has been said to be equal to p. Let's go to the other side of the question. Like we did in the first part, we need to know what a few terms will be. So we're going to start from the lower limit is k equals to 1. We'll start from k equals to 1. So if k equals to 1, we substitute for 1. We have 24 times 2 to the power of minus k. That will be minus 1. That will give us, we make it a positive exponent, so we can have 24 over 2, so therefore that will be equals to 12. That will be our first term, T1. If k equals to 2, we have 24 in bracket 2 to the power minus k, that will be minus 2. That will be 24 over 2 squared, that's 4, and that will give us 6. That's our second term. Remember, we're trying to look for terms that will be equal to p. So we keep expanding. We have k equals to 3. We have 24 multiplying 22 to the power of minus 3. That will give us 24 over 2 cube. 2 cube will give us 8. So that will give us 24 divided by 8, 3. That's our third term. We have, let's try k equals to 4. We have 24 times 2 to the power of minus 4, which is equal to 24 over 16. That's 2 to the power of 4. That's equal to 3 over 2. If we simplify, that's T4. Let's try one more term. If k is equal to 5, then we have 24 times 2 to the power of minus k, or minus 5, which is equal to 24 over 32. And simplifying, we have that as 3 over 4. That will be a fifth term. Note that if we write down the expansion of our terms, we have T1, that's 12, plus we have T2, 6, plus T3, that's 3, the fourth term, that's 3 over 2, the fifth term, 3 over 4. It goes on. We will observe that this is equal to the terms we have here as p. We have p starting from 3 plus 3 over 2 plus 3 over 4. It's also equals to the terms we got from our third term. That's 3 plus 3 over 2 plus 3 over 4, and so on. So therefore, to write a summation of 24 multiplying 2 to the power of minus k from k equals to 1 to 20. I'm going to repeat that here. A k equals to 1 to 20, our upper limit. We have 24 multiplying 2 to the power of minus k is the same as 12 plus 6 plus, we're going to replace 3 plus 3 over 2 plus 3 over 4 and so on with p. And that will be equal to 12 plus 6, that's 18, plus p. So writing that in terms of k, we have that as 18 plus p. Let's look at the second example. In the second example, we have calculate the value of p if the summation of 27 times p to the power of k plus 1 from k equals to 0 to infinity is equal to the summation of 30 minus 3r from r equals to 3 to 14. To find p, what we need to do is, on our left-hand side, we need to find what the summation to infinity of 27p to the power of k plus 1 will be. And to find that, we need to know what our sequence is. So we start from k equals to 0 to know our first three terms. So if k is equal to 0, that's starting from our lower limit, we have 27 times p to the power of 0 plus 1. We replace k with 0. That will give us 27 p, 0 plus 1, that's 1. So that will give us our first term. To get a second term, we put k equals to 1, like we did earlier, 27 p to the power of k plus 1, that's 1 plus 1, and that will give us 27p squared. That's our second term. For our third term, if k equals to 3, we have 27 times p to the power of k plus 1, that's 3 plus 1. I skipped k equals to 2, so I'm going to change that to k equals to 2. We've done k equals to 0, k equals to 1, then k equals to 2. So we have 2 plus 1, and that will be 27 to the power of p3. That will be our third term. So therefore, a sequence would be 27, that's our first term, p plus 27p squared plus 27p3, and so on. We have our first term a to be 27p. To find a common ratio r is equal to our t2, the term in front, divided by the term behind, and that will give us 27p squared over 27p. If we divide, applying our laws of exponent, that will be equal to p. A quick check to make sure that we have a common ratio is our R must also be equal to T3 over T2, and that will be 27P3 over 27P2, just to make sure that we have a common ratio. And if you divide 27 and 27, 1, P3 divided by P2, that's P. So we have a common ratio. Our sum to infinity, because that's a maximum, so we have S to infinity is equal to our first term A over 1 minus R. Substituting, we have A to be 27P divided by 1 minus R. That will be 1 minus P. I call that my equation 1. To find the sum of our right-hand side, we need to find at least the first 3 terms. And because our lower limit is R equals to 3, we start from, if R equals to 3, then we have 30 minus 3 times R, which is 3 times 3. That will give us 30 minus 9. We have 21. That will be our first term. If R equals to 4, we have 30 minus 3 times 4, or 3 times R. That will be 30 minus 12. And the second term will be 18. That's T2. We need one more term. That R equals to 5. We have 30 minus 3 times 5, which will be 30 minus 15. That's equal to 15. That's T3. So our sequence, or our number series, will be the first term, 21, plus the second term, 18, plus 15, plus, we have that. From here, we know that our common difference, before our common difference, we know that our first term is equal to 21. A common difference, D, will be a T2 minus T1. That's also equal to T3 minus T2. And that will be 18 minus 21. So therefore, our D equals to minus 3. To find the sum, because it's an arithmetic series, the sum of our arithmetic series, Sn, equals n over 2. In bracket, we have a 2a plus n minus 1 d. To find our n, note that the summation of k, lower limit bottom to top, will be, to find our n, we have n equals top minus the bottom plus 1. So therefore, our n in this case will be the top, which is 14, minus the bottom, 3, plus 1. And that will give us 12. So substituting back, our S12 will be 12 over 2. 2 times a, that's 2 times the first term, 21, plus 12 minus 1, multiplying our common difference, minus 3. Our S12 will be 12 divided by 2, that's 6 times. If you punch that in your calculator, you're going to have 9. 6 times 9 will be 54. I call that my second equation. So equating our two equations, we have, remember, we've been told that our left-hand side is equal to our right-hand side. And we've been able to get the value of our left-hand side and likewise our right-hand side. So we're going to have the equation 1 equals equation 2. Equation 1, we have that as 27. That's what we have here. So we have that as 27p over 1 minus p. equals, we have our equation 2, that's 54. That's our right hand side. Cross multiplying, we have 27p equals 54 multiplying 1 minus p. We have 27p equals 54 minus 54p. Collecting like terms, we have 81p equals 54, and if we divide both sides by 81 to get a p, we have p equals 54 over 81, and if you reduce to the lowest form, our p equals 2 over 3. Thanks for watching. Bye.